All right, in this explainer, we're going deep underground. We're going to solve a mystery that's hidden right beneath our feet, under every single building, road, and bridge you can think of. Have you ever just looked at a skyscraper and thought, how does that thing not just sink? It sounds like a simple question, right? But the answer? Well, it's this whole fascinating investigation. It's basically a detective story that unfolds long before anyone even thinks about laying a single brick. And this quote from the engineer Charles Dowding, it just hits the nail on the head. Think about that. You can order up steel with exact specs, you can mix concrete just the way you want it, but you can't just order good ground. Nope. Engineers have to put on their detective hats and figure out what they're really dealing with down there.
Okay, so let's get into it. The first step in any investigation is to understand the case, right? And in our story, the case is the ground's great unknown. We're talking about the massive, massive uncertainty of the ground itself.
And let me tell you, the stakes here, they are incredibly high. I mean, if our geotechnical detective gets this case wrong, the results are, well, they're catastrophic. We're not just talking about a few cracks. We're talking about buildings that start to tilt, foundations that fail, and sometimes entire hillsides just sliding away.
So what's at the heart of this whole mystery? Well, it really boils down to a battle between two forces. Picture a giant, invisible tug of war happening underground. On one side, you've got shear stress. That's gravity, the weight of the building, everything pulling and pushing down, trying to tear the soil apart. And on the other side, that's the soil's shear strength. It's how well all those little particles of dirt and rock cling together, resisting that pull. The entire investigation really is just trying to figure out which side is going to win.
Okay, so if you're a ground detective, how do you even start to solve this mystery? Well, first things first, you need evidence. You got to get your hands on the clues. The catch? The crime scene is buried, sometimes hundreds of feet underground. And just like any good detective story, there's a procedure. You don't just start digging randomly. It all starts with assessing the project and doing some field reconnaissance. You know, like getting the backstory on the case. Then comes the really cool part, the fieldwork. They drill what are called boreholes to get down into the subsoil, and they carefully collect samples. This is the physical evidence. That evidence then gets sent off for testing, both in the field and in a lab, before the whole thing gets wrapped up in a final report. So let's talk about the detective's toolkit. What are they using to get this evidence? The most basic tool in the arsenal is the auger. Seriously, just picture a giant corkscrew for the earth. It's simple, it's super effective, and it's perfect for getting that initial peek at what's going on. You know, at shallower depths. But what if the ground is kind of unstable, too messy for a simple auger? Well, then the engineers might bring out the next tool, washboring. Now this is pretty cool. They use a high-velocity jet of water to literally blast through the soil, breaking it all up. Then, that same water carries all the little fragments back up to the surface so they can be inspected. And the whole time, a casing is being lowered to make sure the hole doesn't just collapse in on itself. And then, for the really tough cases, I'm talking dense soil, solid rock, you gotta bring in the heavy-duty gear. This is rotary drilling. Imagine a super powerful, rapidly rotating drill bit that just grinds its way through pretty much anything. This is how our detectives get to the evidence, no matter how deep or how tough the ground is.
Okay, so we've drilled down, we've got our hands on the evidence. What's next? Well, now comes the interrogation. We've got the soil in the interrogation room, and we need to make it talk. We've got to make it reveal its secrets.
And you know, in any investigation, the quality of the evidence is everything, right? It's the same here. You can get what's called a disturbed sample, where the soil structure is all jumbled up. It gives you a general idea, kind of like a blurry photo from the scene. But the Holy Grail, that's an undisturbed sample. This is like getting pristine DNA evidence. It tells you the real story, the soil structure, its water content, its strength, exactly as it exists way down there.
So how do you interrogate soil? Well, one of the most common techniques used all over the world is the standard penetration test, or just SPT. It's a really clever, standardized way to measure the soil's resistance right there on the spot, while you're also grabbing a sample. It's kind of like a 2-for-1 deal.
So here's the play-by-play. It's surprisingly simple, but very precise. First, they take this heavy, standardized hammer. It weighs exactly 140 pounds, and they lift it up into the air,
And then they drop it from a very specific height, exactly 30 inches. Wham! It hits this anvil, and that impact drives a special sampling tube down into the soil at the bottom of the hole they've drilled. Now,
Here is the most important part. The detective, our engineer, is counting every single one of those hammer blows. They drive the sampler down a total of 18 inches. But here's the trick. They ignore the first 6 inches. They only count the number of hammer drops it takes to get through the final 12 inches. And that number, that single number, is the golden clue. It's called the SPT end value.
So you might be thinking, okay, it's a number, so what? Well, this is where it gets really cool. That one simple number tells you almost everything you need to know about how strong that soil is. I mean, look at this. If the end value is, say, between 0 and 4, the soil is very loose. You probably don't want to build a skyscraper on that. But if you get an end value over 50, whoa, that tells you the soil is very dense, solid. It's an incredibly powerful piece of data that directly informs how they'll design the foundation.
All right, so our detective has drilled for clues, interrogated the evidence, and collected all the data. Now, it's time to put it all together and deliver the final verdict on the ground. This is where everything, the samples, the lab tests, those all-important end values, comes together to solve the case once and for all.
And how do they organize all this info? It gets compiled into a master document called a Borelog. You can think of this as the official case file for each hole they drilled. It's a visual summary of everything they found. Here's a layer of sand, here's a layer of clay. Oh, look, here's where we hit the groundwater. And of course, the star of the show, the end values they recorded at every depth.
And that brings us to the grand finale of our investigation. All of those bore logs, all the lab results, they're all put together into one final, comprehensive subsoil exploration report. This is it. This is the case-closed file. It gives the structural engineers the final verdict on the ground, and most importantly, it's their roadmap. It tells them exactly how to design a foundation that's going to be safe and stable on that very specific piece of land.
So, really, the next time you're looking at a city skyline, just think about that. Remember the incredible hidden detective story that had to be solved deep underground for every single one of those buildings. The ground beneath our feet holds so many secrets, and it's this crucial, painstaking investigation that allows our entire modern world to stand tall.